welcome back to education program online with me, teacher Christine, taking you in mathematics for senior 3 and senior 4. So dear learners, we are still continuing on our binomial theorem, and we have already looked at how to expand using the Pascal triangle. And we said that if you are using a Pascal triangle, then you need to construct it. After constructing it, you follow the 4 steps that I gave you. First step, we said you have to identify the values on the line of the power given, and then you have to decrease the power of the first term, and then increase the power of the second term, and then now you can go ahead by simplifying it. So that was method 1. And then method 2, they will ask you to expand any algebraical expression by binomial theorem. So this is what we are going to look at, expanding. This is example, expanding using binomial theorem. So dear learners, if we are asked to expand using binomial, then you have to be very careful, because what they do, they will instruct you to expand using a specific method. So if they say Pascal triangle, then you use that one. If they say binomial, then you use that one. So now in this point, it has brought us back now to our definition of by. That is dealing with the two terms at the same time. Now looking at our example 2, we treat this one as our example now 2, because the other one was example 1, where we are using a binomial. We are using Pascal triangle. So this one binomial, what we are treating as example 2. So binomial example 2, we look at it, say expand the following. Expand the following. Expand the following using binomial. Method. Then they say part A 2 plus x raised to 4. And then we have part B 2 plus 3x raised to 3, and so on and so forth. So dear learners, if we are given a question of this kind and they are asking us to expand using a binomial, then you have to advise you to use this formula. So in our solution, you will have this formula. You say C raised to n base R times A raised to n times x raised to n. So this is our formula, learners, if we are asked to use it to expand using binomial. So for us to interpret this formula, we all know that C stands for combination and N stands for the number of times that an item or an element is the number of item or element in a group. And then R stands for the number of times an element is to be chosen or to be selected. And then A, we say the A is our first term, and then X is our second term. So for a remind, you simply say where C stands for combination. This is combination. And then our N stands for a number of elements. The number of elements. And then our R stands for number of times. A number of times. And then we have A stands for first term. First term. Sometimes we say term 1. First term, or you say term 1. And then we have X. X stands for second term or term 2. Second term. So dear learners, after interpreting that formula, then we can now go straight to our solution for part A. So our solution for part A . So for part A, we have 2 plus x raised to 4. 2 plus x raised to 4. For this, we simply have to move how many steps? 4 steps, including the first starting step. So we shall have C base what? Raised to n, and then R times A times x, close the bracket, plus C raised to n base R times A raised to n minus 1. And then times x raised to n times x raised to n. And then we shall have plus C raised to n base R times A raised to n minus 2 times x raised to n times x raised to n plus C raised to what? Raised to n base R times A raised to n minus 3 times x raised to n. And then plus c raised to n base r times a raised to n minus 4 times x raised to n, close the bracket. So dear learners, to that level we are now going to do what? To substitute our formula. So when we are substituting our formula, we shall now have c, our power here is 4, and then our starting point r will be 0, and then times what? Times a, which is 2, times a, which is 2, times x, which is x. So a here will be powered what? A will be powered by 0. So our a, the power, we remember that our a, the power will keep on increasing or reducing. Then now we have a c raised to 4 base r. So this will keep on reducing, which will be now from 0 to 1. Now it begins to increase. Then times what? Times 2. 2 raised to what? Raised to 4 minus 1. 4 minus 1. And then we have times x times x raised to what? Raised to 1. And then plus c raised to 4, and then the power from 1 here we move to 2. From 1 we move to what? To 2. So the r will be 2, and then times what? Times our a, which is 2, raised to what? Raised to 4 minus 2, times our x, which is raised to 2. And then we shall have plus c raised to 4, then 3 times 2 raised to 4 minus 3 times x raised to 3. And then we have plus c raised to 4, and then 4 times 2 raised to 4 minus 4 times x raised to 4. Now dear learners, up to that level we can now do what? We can now simplify our the value of c. So now when you look at the value of c here, the combination of c minus 1 ratio to 1, it will automatically give us only 0. If you believe that we have c raised to 4, and then here is 0, and we remember that for us to find the combination, you get 4 over 4 minus 0, then ratio to what? Ratio to 4 factorial. So this will give us 4 factorial over what? Over 4 factorial ratio to 4 factorial. So dear learners, it means that when I move 4 to by 3 by 2 by 1, divide by 4 by 3 by 2 by 1, ratio to 4 by 3 by 2 by 1. So you find that all these will automatically cancel off. And then you will get our answer as only 1. So here we shall only get 1, because you will have 4 with the 4 will give us only 1. So there we simply say combination of 4 base 0 is the same as 1. So you get this one as 1 times. Then now we come here. So I want you to look at this. The first term here, you remember when we are looking at the Pascal triangle, we say the first term, the power will reduce. And then the second term, the power will increase. Even when we are dealing with the binomial, you observe, you follow that same step. The power of the second term will increase, begin to decrease. You start from 4 because it is 4, and then when it comes here, it reduces by 1. That will give us now 3. When it comes here, it will reduce by 2, and then it keeps on reducing until it will come to 4 minus 4, which will be 0. So our combination here will now give us 1 times what? Times 2 raised to 4, and then times what? Times 1, which is any number raised to 0, we get 1. So when we come to here, our combination here will be now 4 factorial over 4 minus 3, which will give us 1 ratio to 3 factorial. So 1 ratio to 3 factorial is the same as what? Is the same as 4 times 3 raised to, we shall get 4 times 2 raised to what? Raised to 3. And then times what? Times x. And then when we come to here, we find the combination of 4. So learners, the combination, you will be working the combination on your rough paper, because we don't want it on your working here. So you still come and here and say the combination of 4 base 3. What does it give me? A combination of 4 base 2. So it's the same as 4 factorial over 4 minus 2 factorial ratio to 4 factorial. Sorry, ratio to 2 factorial. So this one automatically will give us 4 factorial over 2 factorial ratio to 2 factorial. So this one means you are going to move 4 until we get 2 factorial. This is 4, 3, and then we have 2 factorial. So we'll cancel with the 2 factorial ratio to 2 factorial. So this 2 will cancel with that. And then you remain with the 4 by 3 over 2 by 1. So this by 2 we get 1, by 2 we get 2. So you get 2 times 3, which will give us 6. So where there is a combination, you will put 6 times what? Times the next, which is here, 2, the first term. So it will be 2. When you subtract the power 4 minus 2, we get 2 power 2. So here we shall get 2 power 2 times now x, which is raised to 2. And then now we also move to the next one, which is the combination of 4, 3. Combination of 4, 3, you do the same. Learners, you say, I will have 4 and then here 3. So when you simplify this, we get 4 factorial over 4 minus 3 factorial ratio to 3 factorial. So dear learners, to this level, we can now simply say I will have 4 times 3 times 3, sorry, times 2 factorial. But because here we have the 3 factorial, so you only move 4 until you get the denominator, which is 3. So you will have 3 factorial over 4 minus 3, you get 1. So you get this 1 factorial ratio to 3 factorial. So that this will cancel with that, and then you have 4 factorial over 1. So 4 divided by 1 will give us 4. So that is how you get the C. And then after getting your C, you will now be able to substitute. Then now you say I will have plus what? Plus 4 times our first term here, which is 2. So the power here will be 4 minus 3 will get 2 power 1. So 2 power 1. And then times our x. Times our x, which is power what? Power 3. And then we have the last one, which is the combination of 4, 4. So the combination of 4, 4 is the same as what? Is the same as 1. Is the same as 1. So you will now have here plus 1 times the second term. The second term here will be 2 power 4 minus 4, which will give us 2 power 0. So this will give us 2 power 0. Then times what? Times x, which is raised to 4. Times x, which is raised to 4. So dear learners, let me try to repeat up again this explanation, because you may get confused somewhere. When you are dealing with the binomial expansion, what happens is, whether you are using a Pascal triangle or you are using a binomial method, the power of the first term will reduce, and then the power of the second term will increase in this case. So for us, when you are dealing with the binomial, the power of the second term will always be reducing by 1. So as you move from the first here, our first here, you find that the power of A will be powered by n, and which is what? Which is 4. So it is powered by n, which is, when we come here, we find that it is raised by 4. But now when it continues moving to another step, the power of the first term here will now be reduced by 1. So which will give us 4 minus 1, which will give us 3. So when it comes here, the power will reduce by 2, which will now move, because if you look at our counting, we have 1, 2, 3. So your power also will be reducing by that steps that we are taking. So at the end of the day, you will find that you have come to get this. And the combination also, you apply the knowledge of combination, which we did it in the previous lessons. So after that, then now we can now be able to simplify this. So you say here in this point, we have now 1 times 2 raised to 4, which is the same as what? It will give us 1 times 16, and then times 1. This one here, it is because the power here is powered by a 0. So this power of n here, we have powered it using n, because we have to make a difference in our working and the formula here. So you will have 1 times 16 times n 1, then plus here we shall have 4 times what? Times 3, 2 raised to 3 will give us 8. So here we shall have 8 times what? Times our x, and then power 1, which is 1 plus 6 times what? Times 4. Here now it will be 4 times x square, and then we have plus 4 times 2 times x cube, and then we have 1 times 1 times x raised to 4. So you find that all these two methods will give you the same answer. So this will give us 16, and then here we have 4 times 8 will give us 32. So this is 32x, and then here we have 4 times 4, which will give us 24, 24 what? 24x square. And then here we have 4 times 2 will give us 8. 8 times ax cube, we get 8x cube. And then we have the last one, which is 1 times 1 times x power 4. We get x power 4. So this is our final answer. Dear learners, for binomial expansion, the whatever, it seems to be very long, but there's no way you can avoid it. As long as they say binomial, you have to show examiner all your steps. Then now we move to part B. So our part B was 2 plus 3x power what? Power 3. So meaning that if we are looking at this, we are going to move how many steps? 4 steps, because the first term will increase by 1, and then the second term will reduce. So we shall have now here C power, here we shall have 3, and then the base will be 0, and then times what? Times our second term, which is 2, and then times our third term, second term, which is 3x, and then we close it. And then you have plus combination of 3, and then here we'll move 1 step, that is 1 times what? First term, which is 2, times second term, which is 3x. And then we shall have our combination. Our combination now will be 3, and then here we have 2, and then times the first term, which is 2, times the second term, which is x. Dear learners, we have come to the end of our lesson.